When we move from a powered cutting tool that only works in 2 dimensions to one that can change the height of the cutting tool, we describe this as cutting in 3 dimensions rather than cutting in two. Cutting in 3 dimensions gives us the ability to alter our cutting strategies in several different ways. Firstly, we can change the depth of the cut, which allows us to have different strategies that give us the ability to cut a portion of the material. In 2D cutting, we can vary the power or the pressure of the tool to allow us to score or mark the material, but with 3D cutting, we are able to accurately control the depth of the cut by a known variable. This gives us the ability to develop more controllable joints, such as housing and rabbet joints. As well as this, we can cut through the materials in multiple depths, which is useful if we have a very thick material, or we are concerned about the edge of the material as the tool breaks through the surface. As well as being able to cut in variable depths, we're also able to change our cutting tool to cut the material with cutters of various widths. With 2D cutting, our kerf is defined by the cutting tool, and we are not able to change whether our cut is with a wide kerf or a narrow one. With 3D milling, we can change the tool so that if we so choose, our kerf can be very small or very wide. This provides us the ability to engrave a fine feature or plane a large surface, all with the same machine. Additional to this, we can change the profile of the cutting tool. We can choose to cut straight and flat profiles, which may be useful for the machining of profiles or slots in work. We can use a cutter with an angled blade, which may be of use if we wish to add an engraving, chamfer, or dovetail to a part. We can cut with a rounded end, which is useful for producing internal radii on a part, or even producing a 3D shape. Additionally, we can choose cutters which have a designed profile if there is a particular geometry we wish to apply to a cut edge, such as you can apply with a spindle moulder or router in a more traditional workflow. Being able to control the depth of the cut provides us the ability to create parts that are more profiled than a basic outline. By varying the depth of the cut, we are able to produce shapes in 3 dimensions, provided they don't have an undercut that prevents the tool from accessing the material. Often, when producing 3D shapes, the tool removes the material in a stepped format before returning to take the final cut to fit the finished dimensions. This is to promote a good surface finish on the final part.